Hi everybody! Today we're going to learn about calculating delta H of a reaction using bond energies or bond enthalpies. So each bond has a different amount of energy that is needed to form it or to break it, and depends on the size of the different atoms. It depends on what type of atoms they are, their electronegativities. Depends on if it's a single or double or triple bond, and all kinds of different things. So you have a table here that lists different bond energies, and that table will be provided for you when you take a test or a quiz. So they're listed, each individual bond and their energies. Now they're all listed as positive values, but when you use them, you have to determine whether you use the positive value or the negative value. So in a chemical reaction, what happens is the reactants, their bonds start breaking, and then the products' bonds start forming. So in a reaction, you break the bonds of the reactants, you form the bonds of the product. Breaking a bond is endothermic. Think of it as like a pencil. If you need to break it, it takes energy. You have to put in energy in order to break it. So in the reactant, since you're breaking those bonds, you're putting in energy that's endothermic, so you're going to use the values as positive values from the table. In the products, you are forming those bonds. So you're taking two atoms that are attracted to each other, putting them together. That is favorable, so that's going to release energy. That's more stable when you form a bond. And so because it's more stable, it's lower in energy, it has to release that extra energy. So when you form a bond, it's exothermic, it releases energy, and so you use the negative values on the table. So to get delta H of the reaction, you basically say that the delta H of the reaction is the sum of the bonds broken plus the sum of the bonds formed. So you add them all up together. Just make sure that for the reactants, you use positive values. For the products, you use negative values, because in the reactants, you're breaking the bonds, and in the products, you're forming the bonds. So the bonds broken, those are in the reactants, and you use positive values. The bonds formed, those are in the products, and you use the negative values. So let's look at a couple of examples. So here's the first example. We want to calculate the enthalpy of the reaction. H2 plus Cl2 yields HCl. Now, most of you, if you look at this, you can imagine what the bonds look like. So if it's very, very simple like this, that's fine. You don't have to draw them. But if it's anything that's a little bit more complicated, definitely make sure that you're drawing them to see what kind of bonds and how many, and if they're single or double or triple or what's going on. So I'm going to go ahead and draw them. I prefer to draw my bonds so I can see them. It gives me a good visual. And there's two there, so you can put a 2 in front, or since it's a simple molecule, I'm just going to draw 2 of them. So again, I can visualize that there's 2 of those HCl bonds. So then, if you're looking for delta H of the reaction and you're using bond energies, you say it's the sum of the bonds broken plus the sum of the bonds formed. Not to confuse this with heats of formation. Heats of formation, delta H of the reaction is heats of formation of the products minus the reactants. Here it's not products minus reactants. Here you're adding them all up. But we just need to remember that in the reactants we're breaking the bonds, so we're going to use positive values. In the products we're forming the bonds, so we're going to use negative values. So you just go through them. Delta H of the reaction equals. So we're going to start with this bond right here. So there's only one of them, so we're going to say 1 mole of an HH bond. And we're going to use the positive value. Positive value for an HH bond is 427. Actually, 436 kilojoules per mole. So I'm done with that one. Next, I have a Cl-Cl bond, just one of those. So 1 mole of Cl-Cl. Since it's in the reactions, I'm going to use the positive value, and it's 243 kilojoules per mole. I'm getting these numbers from the table. So I got done with that one. Next I have HCl's, and I have 2 of these bonds. So 2 moles of HCl, single bonds. And I'm going to use the negative value because it's in the products, and it is 432 kilojoules per mole. Add them all up together, and you end up with negative 185 kilojoules per mole. And that's our answer. So it's an exothermic reaction. Let's try one more. So C2H4 plus Br2 yields CH2Br, CH2Br. This one's a lot harder to imagine in your head, so you definitely need to draw this one. So C2H4 looks like this. Back in chapter 7 and 8, we learned how to draw these. So if you forgot, you need to go back and just review a little bit. So this one, you have 2 carbons. Each of them have 2 hydrogens and a bromine. So it looks like that. So let's go through all of them. Remember, the delta H of the reaction, since we have bond energies, would be the sum of the bonds broken plus the sum of the bonds formed. And if it's in the reactants, we're going to use positive values because the bonds are broken, which is endothermic. In the products, we're going to use the negative values because the bonds are formed. So delta H of the reaction, let's start with CH single bond. So we have 1, 2, 3, 4. So 4 moles of the CH single bonds. And we're going to use positive value because it's in the reactants. And it's 413 kilojoules per mole. Okay, we got done with this one, this one, this one, and that one. Next, we have 1 carbon-carbon double bond. So 1 mole of CC double bond. And we're going to use the positive value. Carbon-carbon double bond is 607 kilojoules per mole. Okay, got that one done too. Next, we have a Br single bond, so plus just 1 of those. Br single. Positive value because it's in the reactants, so it's going to be broken. 228 kilojoules per mole. Okay, got all the reactants done. Let's move on to the products. Let's start with CH single bonds. There are 4 of those. So 4 moles of CH bonds. We're going to use the negative value because those are in the products that are being formed. So 413 kilojoules per mole. Got this one done, this one done, this one done, this one done. Let's go to CBr 1 and 2. So 2 moles of CBr single bonds. Negative value because it's in the products. Those are 288 kilojoules per mole. Got that one done, this one done. So all we have left is just 1 CC single bond. Negative because it's in the products. 347 kilojoules per mole. Add everything up all together, you get negative 88 kilojoules per mole as your answer. So another exothermic reaction. So the key to these is drawing them correctly and practicing. These are the most missed on the test for some reason. It's just so easy to multiply by a different number or something like that. But all it is just adding. So just remember that you're adding them all together. When you break the bonds, you use positive values. When you form the bonds, you use negative values. It's different from heats of formation. In heats of formation, you do delta H of the reaction as products minus reactants. With bond energies, you add them all together.